Hello students, welcome to the channel. In our continuing series Basics Explained, we discuss the basics of topics that you're likely to see on the SAT and ACT. Today we discuss an important topic from SAT and ACT math, the number of solutions of linear equations. So let's begin with linear equations in one variable. Equations of the type shown here, 2x minus 6 is equal to 3x plus 2 are called linear equations in one variable since they have only one variable x. Now, if we try and solve this equation, 2x minus 6 is 3x plus 2, I'll get minus 6 is 8, so x is minus 8. So I find I'm able to solve this equation and get an answer. But what if my equation was 2x minus 6 is 2x plus 2? Can I solve this for x? You will find that it's not possible to solve it for x because when you cancel out the 2x terms, you're left with minus 6 is equal to 2, which is not possible. This kind of an equation has no solution. What about 2x minus 6 is equal to 2x minus 6? Both sides are the same, and it in effect is an identity. And the thing about identities is that they are true for all values of x. So put any x and you will get an answer. So this is true for infinitely many values or infinitely many solutions. So we have seen three cases here. One that gave us a unique solution, the second, no solution, and the third, infinite solutions. So let's try and make a rule out of these three conditions. Let's say I have general equation of the form ax plus b is equal to cx plus d. This is a linear equation in one variable. This will have a unique solution when a, the coefficient of x on one side, is not equal to c, the coefficient of x on the other side. So as long as the coefficients of x on both sides are not equal, you will have a unique solution. This will have no solution if the coefficients of x are equal, but the constant terms are not equal, right? For example, we saw 2x plus 6 is 2x minus 2. This has a no solution because the coefficients of x are equal, but the constant terms are not equal. And this equation will have infinite solutions when the coefficients of x are equal and the constant terms are also equal. For example, 2x plus 6 is 2x plus 6. This is basically the same expression on both sides. So these are the rules that you need to know for finding the number of solutions for linear equations in one variable. Let's now look at linear equations in two variables. But before that, we do a quick sample question of what we have learned. So it says if 1 by 3 times 9 minus 6x is 5 minus 2x, then what is the value of x? So I solve this. So I get 3 minus 2x is 5 minus 2x. And when I compare these, I get the same value for coefficient of x on both sides, but different constant terms. And so I can't solve this equation. The answer is D. The equation has no solution. Okay, let's look at linear equations in two variables. If we have a linear equation of this kind, 2x plus 3y equal to 6 and 3x plus 2y equal to -1, this is called a system of simultaneous linear equations in two variables, x and y. So when you plot this on the graph, you would notice that the two equations intersect at a point, which in this case is -3, 4, and this is called the solution to the system. And as we can see, we will have a unique solution to this system because the two lines are intersecting, right? Now that's one case. Let's look at another case. Let's consider two parallel lines, right? Two parallel lines, for example, represented by x plus 2y equal to 6 with a slope of -1 by 2, and x plus 2y is -2, also with a slope negative 1 by 2. So the slopes are the same, which is why they are parallel, but the y-intercepts are different. So obviously, if you try and find this solution to this system, there won't be any solution because the lines will never meet. They are parallel. So this kind of a system has no solution, right? So this is a no solution system of linear equations. Let's consider a third case, this here. Here, what I have done is I have an equation here, x plus 2y equal to 6, and another equation here, 2x plus 4y is 12. And if you notice carefully, the second equation is just the first one multiplied by 2. So when I multiply the first by 2, I get 2x plus 4y is 12, which means that they are effectively both the same line, right? The first equation and the second equation are the same line. And so this system has infinite solutions because every point on the line is a solution, right? They are the same line. So every point here would be a solution. So we have a third condition of the number of solutions. Now, how do we remember these conditions? It's pretty simple. Let's say my linear equations in two variables, the system is written as a1x plus b1y is c1 and a2x plus b2y is c2. Now, this system will have a unique solution when a1 by a2 is not equal to b1 by b2, right? So for example, 2x plus 3y is 5 and 3x plus 2y is 6. So a1 by a2 is 2 by 3 and b1 by b2 is 3 by 2. They are not equal. So I can solve this for a unique solution. This system will have a no solution when a1 by a2 and b1 by b2 are equal, but that ratio is not equal to c1 by c2, right? For example, 2x plus 3y is 5 and 4x plus 6y is 15. So here a1 by a2 and b1 by b2 is 1 by 2, but c1 by c2 is 1 by 3. So this condition is satisfied. The lines will be parallel and there would be no solution to the system. And the third case, when all the three ratios are equal, 2x plus 3y is 6, 6x plus 9y is 18. So a1 by a2, b1 by b2, and c1 by c2 are all 1 by 3. And so this system will have infinite solutions. So this is important, right? You need to remember these conditions for solving questions on number of solutions for a linear system. So let's do a sample question. There is a system of equations here and k is a constant. X and y are variables. For what value of k will the system of equation have no solutions? So for no solution, a1 by a2 should be equal to b1 by b2, and that should not be equal to c1 by c2. So 2 by 5 should be equal to minus k by minus 2, and that should not be equal to 14 by 5. Now 2 by 5 is not equal to 14 by 5. So if I make these two equal, my system will have no solution. So 2 by 5 is equal to k by 2. So k is equal to 4 by 5. So for k equal to 4 by 5, the system will have no solutions. So that was the conditions that you need to remember for a linear equation in one variable and a system of linear equations in two variables for no solution, unique solution, and infinite solutions. If you found this video useful, please hit like and subscribe to the channel. Let me know in the comment section what other concepts you'd like me to take in future videos of this series. I'll see you guys in a new video soon. Take care. Bye-bye.